Greetings everyone and welcome to question number 31. In this question we have the line D has a tangent at points 1, 3 of fx. So as you can see, 1, 3 f of fx, of the function fx. And we are as the derivative of f1 plus f2. What is their sum? Now one thing we have to understand here, whenever we have fx, its derivative will always be equal to the slope of the line. So the slope of line D in this case. Therefore, if we have the derivative of f2, f1, f3, whatever, still it's going to be equal to the slope of the line, because as you can see, it's tangent at points 1, 3 of fx. Therefore, derivative of fx will always remain the same. It doesn't matter what value we give to fx. If it's 1, 2, 3, still the slope will, the derivative of fx will remain the same. So by saying that, we know that also the derivative of f1 is equal to the slope of this line. So what is the slope of this line? As you can see, we have an angle over here, which is, let's name it alpha. Now, as you can see over here, we have a right triangle. So I'm going to draw it here so it will be in a better view. So we have angle alpha, we have a right triangle over here, so the height is 3, and from -1 to 1, that is if we take the absolute value of 1, so we see the distance, it's 2. Now what do we have here? This will be equal to the slope of this line. In this case, it's equal to the tangent of alpha. The tangent of alpha, what is it equal to? It's the opposite side. For example, from this angle, the opposite side, which is 3, over the opposite side from the hypotenuse, which in this case is 2. So what do we have here? We know that the derivative of f1 is equal to 3 over 2. Now we found the derivative of f1. Now we have to find f2. Now what do we know here? We know that fx is always equal to y. So if we give x the value of 2, as you can see we have here 2. What is the value of y when we give x the value of 2? As you can see, it is equal to 0. Therefore, f2 is equal to 0. And all we have to do now is just add them up, because we are as their sum. So we have 3 over 2 plus 0, which is equal to 3 over 2. So this is the logic and the process you need to follow to get to the right answer. This is something that you should never forget. The derivative of fx in these kinds of questions will always be the slope of the line. Welcome to question number 32. In this question we have limit of the third root of x plus 27 minus 3 over x as x approaches to 0. The mistake that many students do is to replace x for 0. Why it is a mistake? Let's replace x for 0, and we will immediately understand why that is wrong. So instead of x, I will put 0. So 0 plus 27, it's going to be equal to 27. 27 can be written as 3 to the power of 3, and after that, the power of 3 would eliminate the third root, and after that we will be left with 3. So 3 minus 3, it will give us a numerator of 0. If I replace x with 0, also I will have a denominator of 0. So we have an undefined solution, which means this solution is wrong. Therefore, we have to make sure that we bring these expressions into the state where we will not have a numerator or a denominator equal to 0, because we try to find the solution instead of having an undefined solution. So how do we do that? Now when we look at these expressions, what we can do, we can take the derivative of these expressions. How do we take the derivative of these expressions? So let's see. We have the third root of x plus 27 minus 3. So we take the derivative of this expression. And I will do the same thing also with the denominator. So I will take its derivative. Now, what is another way of writing the expression, the third root of x plus 27? Another way of doing so is to write it as x plus 27 to the power of 1 to the power of 1 over 3 minus 3. Don't forget, I will take the derivative of this expression. So I will do the same thing with x. So how do we find the derivative of this expression? Now, as you can see, we always have to look at the numbers that have x as a factor. So as you can see, 3 doesn't have x as a factor, so its value becomes 0. So we look at x plus 27. Now what do? The exponent, we bring it to the front. So we have 1 over 3 times x plus 27 to the power of minus 2 over 3. And after that, we do the same thing. Now we have the exponent here, we have the exponent 1. So when we bring 1 into the front, x to the power of 0, it is 1. So here we have 1 times 1. Now, what do we have? We have 1 over 3 times, what is another way we can write, how can we write this expression in order for us to get rid of the negative exponent? We can write it as 1 over 3 times x plus 27 to the power of 2 over 3. So this is another way we can write this exponent. I will take this expression another step, a step further. So we have 1 over 3 times the third root of x plus 27 to the power of 2. Now I know that I will certainly not have a numerator or a denominator of 0, so I can now replace x for 0, and by doing so I will be able to get the right answer. So let's replace. We have 1, 3, third root of 0 plus 27 to the power of 2. So what do we have here? We have 1 over 3, we have 27 to the power of 2. So what is another way of writing 27 to the power of 2? Another way of writing it is 3 to the power of 3 all to the power of 2. That's another way of writing 27 to the power of 2. But since I have 3 to the power of 3 and all to the power of 2, can I switch sides of these exponents? Yes, I can do it, because the value of this number will not change. I will still get the same value. So instead of writing 3 to the power of 3 and all to the power of 2, I will write it as 3 to the power of 2 and all to the power of 3. And the only reason I did it is to get rid of the third root. So I have the third root of 3 to the power of 2 all to the power of 3. So the exponent and the root is cancelled. So what do we have? We have 1 over 3 times 3 squared is 9. So the answer to this question is 1 over 27. So this is the right answer for this question, and this is the process that you need to follow to get to the right answer. Please don't make the mistakes that many students do. On the first step, they try to substitute x for whatever value is given to x, and they get to the undefined solution, which is the wrong answer for this question. So please follow this process, and I promise you, you will never be mistaken, and you will save yourself a lot of time on your exams. This was question number 32, and I will see you on the next one. Welcome to question number 33. In this question, as you can see, we are dealing with integrals. We have integral 3x squared times derivative of x over x to the power of 3 plus 1 all to the power of 5. The first thing that we have to do here is to find the relationship between the numerator and denominator. So for simplicity reasons, I will write x to the power of 3 plus 1 as a. So I will equalize it to a, only for simplicity reasons. And I will take the derivative of both sides. If I do that, what do I have? I have 3x to the power of 2. Don't forget the derivative of 1, it's equal to 0 because 1 does not have x as a factor, times derivative of x, which is equal to derivative of a. So what I did here, as you can see, this expression is the same as the numerator, so I equalize that to dA. So we have integral of dA over, we have the expression x to the power of 3 plus 1 equal to a, so I will take a to the power of 5. What is another way I can write this expression? Is a to the power of minus 5 times dA. So I just switch sides of a to the power of 5. So what is integral of a to the power of minus 5 times dA is equal to a to the power of minus 4 over minus 4 plus c. C in this case represents any other value. So what I did here, to a to the power of minus 5, I added plus 1. And that power, that exponent, I divided it by the same exponent, which is minus 4. Now all I have to do is replace a with the expression that we are given here. So we have x to the power of 3 plus 1 all to the power of minus 4 over minus 4 plus c, which represents, as I said, any other value. And this will be the right answer for your question.